Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question. Question number 4 of 2014 NEET physics paper. Now students, let us solve the next question. Question number 4. This is this chapter is about force. Newton's laws of motion. Here we have a system consisting of three masses. These are the three masses given: M1, M2 and M3, connected by a string. This is a string that goes over the pulley, passing over the pulley P. The mass M1 hangs freely and M2 and M3 are on the rough horizontal table. This is a table with frictions. There is a friction, and coefficient of friction is mu. The pulley is frictionless and of negligible mass. Here on the surface of the pulley, as the rope moves, the pulley, there is no friction here, so here you will take mu equals to 0. Only on the surface you have to consider. If there is no friction, then this string will only slip. It will slip over this pulley, and the pulley will never rotate. Because to rotate that, it should have friction, and it is massless pulley, so that is always given. We can take into consideration the mass of the pulley as well, and there is friction as well. In that case, it will be a little difficult question, but that is done in rotational motion, in considering the moment of inertia of the pulley and torque equation. But that is not required here. It's just a very simple plain question. The pulley is frictionless and massless, so there is no mass, it's negligible mass, so you don't have to think much about the pulley. The downward acceleration of mass M1. What is the downward acceleration of mass M1? Suppose that is A1, and what is that answer? Now, if I solve this, might be there is a simple shortcut method. The whole thing, two blocks here and one block there, when it starts moving down, the two blocks simultaneously moves forward. So when this comes down, this moves forward. These two blocks are moving this way, and the first block is moving down. So this is how the movement occurs. Okay. What I have to say is that if this is the situation, then you can think of these three blocks, because whatever will be the acceleration of M1, the same acceleration will be for M2 and M3 blocks, because they are connected by strings. Same string passes over this. This is constant motion. In constant motion, they are connected, so all the three blocks will have same acceleration. So if they have same acceleration, I will treat the three blocks as one block, but I have to find then net force acting on those blocks. The first one, if I draw the free body diagram to make you understand, this is the pulley. Here the rope goes, Here is one block. The blocks are like so. One interesting point is that by a string, same string actually pulls everything. You can see that this is M2, this is M3, and this is M1. Now, this is support, some support is there that we are not interested in. If I draw the free body diagram of this one, mg, m1g downward, tension will act in the upward direction. Suppose the tension is T1. In the diagram, it seems as if one string is there. You can take two strings. If I take two strings, then tension will be also different. So, if you look the diagram, it seems as if one string is actually pulling. There is a single string. If I do that, then my tension here and there will be same. So for the time being, I consider the tension to be same. So if it is T1, it will also be T1. Then from here also, it will be T1, it will be T1. In the pulley, because there is no mass here, so tension will remain same, T1, T1. What I'm getting is that this part, this tension will cancel, this part, this tension will cancel, this part, this tension will cancel. The tension actually is cancelling. And anyway, if I want to write, then I can write and see what is we're getting. Finally, we'll have some tricky solution to this. This one, we are assuming that, or it is said that is moving downward, accelerating downward. The downward acceleration of M1 is asked. That means it is moving downward, with supposing that the acceleration is A or A1, because the same acceleration, so we don't have to take A1, A2, I can take. The difference, M1G minus T, because all tensions are same, so I will consider T only. So there is no need to write T1, to write T equals to mass into acceleration. If I look at this body, M2, obviously then this tension is different from this tension. It's obvious from here. Because if these two tensions are same, then it will not move. This will not move. So this tension is more than this tension. This is tension 2. So I will consider 2 here. I will consider T1 here. T1 minus T2, and also there is a friction which will act in opposite direction, because the body has to move in this direction with acceleration A. This also has to move with acceleration A. This block is opposed by frictional force, and that is mu into m to z, mu n. Here mu n is m to z. In this case, it is mu m3z. So if I draw the free body diagram of this one, then this will be T1 minus T2 and minus of mu m to g equals to m to a. Similarly, for this case, third one, I'll write that the difference is mass into acceleration. This side, the net force will be this side, because the block is accelerating this side, because this block is moving down. So this force minus this force, I'll write the equation T2 minus mu m3g is m3 A. If I add all those equations, if I add those three equations, the force diagram I do for all the three blocks, and then this equation, force equations, add them together. If I add them all, this will cancel and this will cancel. This is what exactly I was telling you, that the tensions will cancel out. So here the tensions are different because the strings are different, so this is not the same string. This diagram is not right. This is not the same string. This is a different string. Okay. Now the left side will be m1g minus, just let me write, m1g minus mu m2g minus mu m3g. So this is the terms in the left. Right terms, a being common, m1, m2, m3 will be there. This is equal to m1 plus m2 plus m3 times a. We are interested in a, so a will become m1, g taking common, m1 minus mu m2 minus mu m3 into g divided by total mass. So now this is the general expression for acceleration. It says that assuming m1, m2, m3 are same mass and m, so if I substitute that value, m1, m2, m3 being same, so in place of m1, m2, m3, m1, m2, m3, you put m. Put m here, so you will have m minus mu m divided by 3m into g. M taking common and cancelling out, this is 1 minus 2 mu divided by 3 and into g. So this is the acceleration of the block if this is the situation, that mass being same and A accelerates, it will accelerate with this acceleration. If I see the option, then g into 1 minus 2 mu by 3, g into 1 minus 2 mu by 3, so this option is correct option. So this is the answer to this question. What is the shortcut method is that, in short, without writing for actual calculations of all these equations, you can simply write solve it also. The short trick is that if I consider 1, 2 and 3, these three are the system moving or accelerating with same acceleration, then these three blocks together, because the mass is same, obviously the mass is same, it's given that the mass is same, so the total mass is 3m. This mass into acceleration is the f net. This is what is the situation. That means the I want A is f net divided by 3m. What is net force? What is the force which is pulling it down, and what is the opposing force? What is the force pulling it down? Is m1g. m1g, so net force, how to calculate net force? Here m1g is pulling down, mg is pulling down, and what is the force that is resisting? That is mu mg is the frictional here opposing this motion, here also mu mg opposing the motion. So actually 2 mu mg is opposing and 1 mg is pulling it down. So this is the driving force, this is the opposing force. So therefore, because the net force is downward, so it is mg minus 2 mu mg, this is the net force. If I know the net force, you can see mg taking common, this is 1 minus 2 mu mg, this is the net force, and when you know the net force divided by the total mass, that gives me the acceleration, then m will cancel and I'll get 1 minus 2 mu by 3 into z. This way also you can solve. You pause the video and see It might be a little fast, I've explained to you this one, but it is easier. If the system is moving down or in this direction or that direction, you have to find the net force. Which are the forces which are actually supporting the motion and which are the force which opposes the motion. You take the difference, and that is the net force, and divide by the total mass of the system. Here are 3 blocks, so 3m, divide, you get the answer. Okay, thank you.